Let's talk about a thing or two regarding source transformation. In the sheet regarding basic laws, I have this topic over here, and the video in which I have discussed this particular sheet, I will be linking that video in the description box, so make sure you check the description box. So let's move on to the topic, source transformation. Source transformation is applied when you have to convert a circuit with voltage source into a circuit having current source. Okay, so this is what we are doing. We are converting a voltage source into current source and vice versa. So what we are doing is, if you are having a voltage source in series with a resistance, you can convert it into a current source in parallel with a resistance. We are applying basic Ohm's law over here. The value of current source would be V upon R as per Ohm's law. The value of resistance, however, would not change, but the position will. Here it is in series and here it will be in parallel. The value of current, however, will not change. Okay. Similarly, if you are given this particular circuit and you wanted to convert into a voltage source, okay, so what we are doing is we are still applying the basic Ohm's law, and here the value of voltage source would be I into R. The value of resistance will not change, but the position will. Here it is in parallel and here it will be in series. The current, however, will not change. And one more thing to be kept in mind is, wherever the positive terminal is, there will be the arrowhead and vice versa. Okay, important things to remember, that this concept is not valid for ideal sources. If in the question it is mentioned the sources are ideal, do not apply source transformation. Okay, it is applicable to both dependent and independent sources. And few small things to be kept in mind is that ideal voltage source, the internal resistance is 0, and an ideal current source, the internal resistance is infinite. Okay, so let's go to the questions to understand the source transformation better. We have this particular question over here which was asked in ESC 2018. What we have to do is we have to find out the value of I1, I2 and I3. Okay, this is your I1, this is your I2 and this is your I3 over here. Apart from that, you are given two current sources of 5 ampere and 3 ampere. We are having three resistances, 4 ohm, 3 ohm and 5 ohm over here. From this particular circuit, we are having two things in mind because of KCL at these two nodes. Okay, when you apply KCL at these two nodes, you get the sum of incoming currents equals to sum of outgoing currents. So you get IA equals to I2 plus I1. Okay, and the value of I1, IA is given to you 5 ampere, so this will be 5 equals to I1 plus I2. Similarly, you are going to apply KCL at this particular node as well. So the sum of incoming current would be equal to the sum of outgoing currents. So you get I2 equals to I3 plus IB. Okay, and the value of IB is given to you 3 amperes. So I2 will be I2 equals to I3 plus 3. So these are the two equations to be kept in mind. Okay, why? Because we are going to use it further to calculate our value of I1, I2 and I3. What we are going to do is we are going to apply source transformation, because here you are given a resistance in parallel to a current source. Okay, this is a clear indication that you can apply source transformation. On applying source transformation, you get this particular circuit over here. If you are having a resistance in parallel to a current circuit, that will be converted to a resistance in series with a voltage. Okay, so this is what we are going for. So your uh, current source in parallel to a resistance is converted into a voltage source in series with a resistance. On converting this part over here, you get this and this. Okay, we have applied basic Ohm's law. I into R equals to voltage, 5 into 4, that is 20, and 5 into 3 is 15. And wherever the arrowhead is, there will be a plus terminal. Here arrowhead is up, the plus terminal is up, and here your arrowhead is down, your plus terminal is down. Now this part, however, is not changed, so this I2 will not change and the resistance will not change. So we are going to calculate the value of I2. How? Based on total voltage upon total resistance. Okay, we are applying Ohm's law over here as well. Okay, we have I2 equals to this voltage sources are added 20 and 15. Why they are added? Because of this. Okay, here you see, if your plus terminal meets the minus terminal, the voltage are added. Okay, here your plus terminals meet the minus terminal, your plus terminal meets the minus terminal, so you're adding it. Okay, So here it will be 20 plus 15, and the total resistances here, these three resistances happen to be in series, so we are adding them in such a fashion. Okay, the equivalent would be so this is what we get, and the value of I2 would be this many amperes. Now we are putting this particular value in these two equations over here to get the value of I1 and I3. You get I2 and you put it into these two equations, I2 over here and I2 over here, so you can easily get the value of I3 and I1. Okay, so this is your question solution, and you get I2 as this, I3 as this, and I1 as this. So this is all for source transformation. The question is not difficult. The only thing to be kept in mind is that if you get a resistance in parallel to current source, or a resistance in series with a voltage source, only then you apply source transformation, otherwise not. So this is all for today.